Okay, so today we're gonna have the privilege to integrate trig function. Okay, very lucky. Okay, now I thought at this point it would be nice for you to see what it looks like. What do you call it? This formula sheet. So I already copied it as it is. Not all of it, but the stuff that we need for today. So what you will have is you'll have a list of functions. I also put the polynomial, but mainly I'm focusing on the trig function and their derivatives. So you don't need to remember it, which is quite nice. Okay? And what we're going to do, we're going to use this table to calculate integrals. We'll start with very, very basic integral, obviously trig integrals. So if the derivative of sin is cosine, Olivia, you ready? I'm going to ask you a question. The derivative of sin is cosine x. What will be the integral, which is the antiderivative of cosine x? Sine x. And obviously plus the c. Okay? Slightly trickier, what will be the integral of sine x? So we're working backward. Now, here was easy. When I asked you what's the integral of cosine x, oh, you just went to sine x. But when I asked you what's the integral of sine x, well, I don't have... So it's what? So it's going to be minus cosine x plus c. Why again? Because I know that the integral of, maybe I'll write it down, the integral of minus sine x, that's what my table tells me. The integral of minus sine x dx is cosine x. Now I can get the minus out of the integral because it's a constant, minus 1. So therefore I can time it by minus 1 and then I'll get this integral, okay? So if I've got that minus here, it will come out on the other side. One more, you ready? Okay? For some reason, maybe they'll ask you to calculate the integral of cosec. So what cos square x, okay? We don't know, we can't just find out the integral of cosec x because I don't have cosec. So what will be the integral of cosec? Minus cos x. Okay, so that's pretty easy, right? Okay, I'll pause, clear out some space, go to next level. So now we're spicing things up a bit. So not just to find the integral of cosine x, but find the integral of cosine 2x. Okay? So I'm trying to kind of develop an instinct. What is our suspected function going to be? Okay? There will be sine x, but you know, cosine x becomes sine, the integral of cosine x is sine x. So the integral of cosine, if I do the derivative, I'll go there. If I'm going there, it will be something with cosine. But it has to be 2x. You know, because if I do... Okay, so let me just, maybe I should remind you first. Let's forget about that for a second. What will be the derivative, okay, of cosine 2x? Maybe I'll write a little bit down. Let's just remind us this. Yes, I need to remind you. So what will be the derivative of cosine 2x? Okay, remember this is we use the chain rule.
Okay.
So the cosine 2x will become sine 2x, or in fact minus sine 2x. Okay, I should actually start with. Is that what I really want? Yeah, I don't want cosine. Sorry, I meant sine 2x. Yes. Okay, the derivative of sine 2x will be cos 2x. Okay, that's what the chain will tell me. Yeah. Do the derivative of that and time by the derivative of this, which is 2. So it will be 2 cosine 2x. Okay? Now I'm looking at that. Okay, that means, what does this thing tell me? Tell me is that 2 cosine 2x dx, the integral of that will be that.
Okay.
Yeah?
And you can divide it by 2.
Fantastic. So this is my suspected function, okay, the integral of this. But we see from this that this is, we see that 2 times that is the integral of that. So if I don't have that 2. So how am I going to make that 2? I'll write that 2 here, but I need to time it by half. Yeah? Okay, you already realize it, so because you already figured out that you need to divide by 2.
Okay,
yeah? Should I write like this? Yeah. So we can, like last time, I said, okay, now I want to know, I don't want to have a 2 here, so I'm going to get rid of that 2. I'll divide by 2, but then I must divide that by 2. 2. Okay, that's better. Okay, plus a c. Okay, the other one, which one is it? Okay, let me just save some time here. Okay, so now we've done the cosine of something. Now I'm going to do the sine. Maybe we'll just try and guess what will be a suspected function. We'll have to multiply it by something later.
Minus cos.
So just like sine x, I'll write it down here. The integral of sine x dx was minus cosine x. So it's going to be minus cosine. Is it going to be x, or what would you reckon? X over 2. And we have some. You time it by 2. You're right. Okay, you're right. Let's just see why. Okay, because if I take this, I do the derivative of minus cosine x over 2. Let's do the derivative of that. Well, minus cosine x becomes sine x, right? I put a minus here, so I'll get rid of that minus. So it's going to be sine x over 2. But now we need to time it by the inner function. So it's going to be half times sine x over 2. Okay, or sine x over 2 divided by 2. Now, I don't want that divided by 2, so I need to multiply it by 2. So I need to multiply it by 2. So the answer is, as you said, minus 2 cosine x over 2. Okay, so next one, I'll just choose one of these nasty ones. Okay, remember, if this table tells you if you differentiate that, you get that. But it also tells you if you integrate that, you get that. So let's integrate not sec square x, because obviously if I just integrate sec square x dx, that's simply going to be tan x. That's the c. Yeah. Let's integrate sec square 4x. Okay? We can already guess what's going to be the function. There will be, we always just eventually dividing or multiplying by something. So what will be the trig function? So sec becomes tan. So it will be tan 4x. Okay? And we're going to have a plus c, and we're going to have a multiple here. Can you think what will be the, what do we need to multiply or divide by? Without me doing that? So what you got to ask yourself, I'll write it in a minute. You got to think, okay, it's going to be something like that. Now, if I differentiate that, I must get that, right? Now, if I differentiate the tan 4x, I will get 6 squared 4x, but now I need to multiply, it will be multiplied, so I need to divide it by 4, because that 4 will jump out. Let's just check that to make sure we are right. So I'm going to actually differentiate straight away 4x divided by 4 straight away, because we, for the first time, really, it's quite cool. For the first time, we guessed the solution straight away, and hopefully we got it right. So the derivative of that, tan 4x, it tells us that it's going to be sec squared 4x divided by 4. That's just a constant. But now we time it by the derivative of the inner function 4x, so we need to time it by 4. That cancel out, and wow, we got exactly what we need. So that is correct. That's the right solution. Okay, I'll pause here, clear it up. Okay, now all the questions we had so far were really very immediate solution. You just use that, we integrate one of these functions, and the answer was that. Okay, maybe we had 4x or 2x or x over 2, so we had to multiply them by 2, divide by 4, but it was immediate solution. Now we're looking at a situation where we have like a mix, and we have cos cube x times sine x, or sine 4x times, so we've got a mix. You're not going to find it here. It's not here. Okay, maybe these ones. If you find one of those, that will work, but that will be easy. So we're looking at that. What we do. So the idea is that one of them will be the function, a function, and the other one will be the derivative of it. Remember that one, okay? So it's a lot about intuition. So the function, okay, is going to be the one with a higher power. That's it. So that's some kind of function of x, cosine x cubed. And the other one will be what, the derivative of it. What do I mean? Okay. I'm getting stuck exactly. This is the same lesson. Okay. So let's just pause here for a second, and let's look at cosine to the power, or not cosine 4x. Cosine x power 4. Let's do the derivative of that. I should write it down here. So, cosine power 4x. The derivative of that using the chain rule will be 4 times cosine to the power 3x. Okay, so we did just the derivative of that power 4 times the derivative of cosine x, which is sine x almost. It's minus sine x, right? So I'm going to stick in a minus there. Okay? So the derivative of cosine power 4x, the cosine became power 3. Then I also have a sine because cosine becomes sine. And I had that 4. So it's that. Now this is very similar to that.
So, okay.
Let me just pause here.
To,
So what we're seeing, I'll repeat again, is that if we take the thing that we suspect, the one with the higher power, if we do just the derivative of that, what we get is this. Okay? And that's very similar to that, of course, up to the constant 4. So I'm going to get rid of that 4. I don't want that 4. I'll divide by 4, but that means I need to divide the original function that I do in the derivative of 4. So the answer will be cosine power 4 x divided by 4. Okay? And obviously, as always, add a c. Okay? I'm going to do another question like that. Let me find another question. Hang on. No, sorry. I made a mistake here. Okay? Lucky. We saw that this will give you a minus. But we don't have a minus. So I need to get rid of that minus, I need to time minus 1. So that will turn that into plus, but that means that I have a minus here. So really, the answer is minus cosine power 4x divided by 4. Okay, let's do another one. Okay, so I thought actually let's just do another question like that to make sure we're all right. So now again I have two trig functions, and what's important, I didn't say, is that their power is not the same. And that's actually important, you'll see in the next example. So one of them will be the function, in this case it's this one, and one will be the derivative of that. So what would you reckon will be our suspected, what are we looking for? What will be the answer? What will be the function? So here we always go with the one with a higher power, right? Here our function was cosine power 4x, and we differentiated that with the cosine cube.
work out the derivative.
So what can I suggest? What do you suggest putting here? I need to kind of start with something.
Sine.
It's going to be a sine, right? It's going to be a sine. Okay.
Cube.
Now it's going to be sine cube because it was sine square here, so it's 1 above. Then what am I going to have here? I have to have 2x. I can't, if I had x or any other thing, it's not going to become suddenly sine square. So I have to have 2x. It's going to cause problem for me there will be some constants there. We know that, but it has to be 2x. Whatever you have here, you have to have there. And in fact, you also have to have here. So if I had, let's say, this one is 2x and the cosine was 3x, then you can't do it because, okay? So now at this point, I'm going to try and stretch you a bit. No, that's going to be difficult. Let's just do it the long way around. So that's my solution, suspected solution. Okay, I know I'm going to have to either multiply it or divide it by something. We are recording. Okay. So at this point, if you can try and guess what number I'm going to put here. Okay. What number will you have? What number that you're going to have here? We're going to have to divide it by at least one thing.
You'll have a 3.
There will be a 3. I'm going to have to divide by 3 to get over 3 here. Okay? But there's going to be more than that because these 2's are going to start jumping as well. In fact, you can figure out what
I'm just confused.
not sure. Okay. So let me just say it and then we'll show it. So what will happen is if you're going to do a derivative of this,
Yeah.
I'm going to write it, but I'm not going to actually write the whole thing. If you're going to do a derivative of this, it's going to be 3. Okay, the 3 will jump out. Sine squared 2x. I don't want to write it. I'll write it in a second. Okay, we'll have 3 sine squared 2x times cosine 2x, because sine becomes cosine. But also what will come out, other than the 3, the 2 will come out as well, right?
So you need to divide minus 2x.
well, not mine, divided by 3 and divided by 2. Now we divide by 6. I'll try and show you what happens, okay? So let's do a derivative of that. It's going to be 3 sine squared 2x, yeah? And then time it by the derivative of sine 2x, which is cosine 2x. There is a function inside the function, right? You've got something cubed, and that something is actually sine. And inside the sine, it's actually 2x, not just x. So the 3 comes out first, then it becomes cosine 2x. And then the 2 comes out as well. So I need to time it also by 2. Okay? So altogether, I already timed it by 6. 6 sine squared 2x cosine 2x. Which obviously is not what I had. So if I divide this by 6, as I guessed, that will be perfect. Okay? Now, you don't have to kind of guess it straight away. If you're not sure what it is, okay, that will come with time. If you're not sure what it is, as long as you guess that it's going to be sine cubed 2x, then do the derivative of sine cubed 2x, see what you get, divide by, you need to divide by, multiply, you need to multiply, and fix your solution. Okay? Cool. Let's pause here. Right, our next kind of mixed function is, again, sine, cosine, but the difference is they have the same power, in which case is 1. Okay, in fact, if they have all the same power 2, then we still can't do it. But so this class of question is sine times cosine. They have to have, well, later we'll see when they don't have the same argument thing, but for now they must have the same kind of x. See, it's different to that. I'll just pause and clear. Okay, so when we have that, we can't use our method. Why can't we use our method? Actually, why can't we use the derivative? Let me just pause for a second. I'm going to think about it for a second. Okay, so there is a little bit of an issue here I need to figure out, and I'll let you know later. So when we come across this, okay, when they have the same power, we use a trig identity, which you haven't learned yet. I think when you get to trig this year, you will learn this, okay? So 2 sine x cosine x is simply sine 2x. It's a double angle triangle identity, okay? So what we can write, before we integrate, we can rewrite it as sine 4x. Okay, why 4x? Because, you know, here it was for x. But if I put 2 and 2 here, then that obviously will be 4. It's basically that the double angle sin of a double angle is equal to 2 times sin of half of that times cosine. Does that make sense? Yeah, all I did is just, okay, you know, instead of having, here, if this is x and this is x, that must be 2x. So if this is 2x and this is 2x, that will be 4x. Okay. Yeah? So it's a trig identity. It takes a while to kind of manipulate it, and you will do that in class, I'm sure.
But then the check to divide by 2.
And I need to divide by 2. You're right. Okay? So I need to divide by 2 and obviously do the integration. Okay? So, because you've got a 2 here. You really should have a 2 here, but there isn't, so we divide this way. In other words, I'll rewrite that as that. Okay? And now, derivative or the integration of sine 4x, that's not a problem. I can just use the table. Okay? So I'll take this is something I haven't shown you a lot, but I think it's not bad. Because I'm dividing by 2, I can take that half out of the integration. Half constants don't do anything on the integration. So let's write it like this. Okay? What is the integral of sine 4x? Okay? Well, the integral of minus sine x is cosine x. So the integral of sine 4x is going to be minus half cosine 4x, right? The minus, because minus sine becomes cosine, so just sine will become minus cosine. I still have to work with 4x, but now we're going to also, 4 will jump out, right? So I need to divide that by 4, right? So, and obviously plus c. So the answer is going to be cosine 4x divided by 8 plus c. And there's a minus, yeah, there is a minus. Okay? Right, let's just pause here. Okay, so I had a very interesting discussion with Olivia, and what happened is that I realized there's another way of solving it. Okay? And I don't want to show you the full way. It's not easier, I don't know, we reckon, Olivia reckon, if you get this trig identity, you can do it, that might be easier. But just to let you know, maybe you can think the same thought that I had, and I want to just kind of satisfy you, don't get too confused. Because what we can do, so that's one solution, okay? The other way you can look at it and say, okay, but maybe the original solution is sine squared to x. Because if I do the derivative of sine squared to x, that's going to be 2 sine 2x, went to 1, times cosine 2x, and then I need to multiply it again by 2 because of that. So the first 2 comes out here, the second 2 comes from there, so it will be 4. So you can see I have something very similar to that, except I've got an annoying 4. So I can actually divide it by 4 as well. Oh, here we go, I'm solving it in the other way, okay? So if I'm dividing that by 4, I also divide that by 4. What does that mean? That means that another possible answer is, okay, sine squared to x over 4. Obviously plus a c. Now, then there's a problem. There's a problem because I used two different methods, and I got two solutions.